Hey math kids, today we're going to talk about logarithmic functions, and we only have one example, but it's pretty involved and it has quite a few parts. So we are going to start with this, log base 2, x minus 1 plus 1, and it says state the transformation which maps, so part A, that maps y equals log base 2 of x to f of x. So basically, it just wants us to say what we did. So the translation is just 1, 1, because this is going to move to the right, which is the positive direction, and it's also going to move up. Remember, this is just in the form x comma y, and so this is the answer they want for part 1. I think this stuff's a little silly, but just knowing that this moves to the right and moving up 1, that's really all I care about that you get out of this. Okay, anyway. I'd like to actually talk about that a little bit more because I just don't really like this notation. So if we just have a log function, we're going to cross at 1. And so this would just be like log base 2 of x. Now, this plus 1, or let's do the negative 1 is going to move it to the right one. So it's now going to look like that. And so that would be like log base 2 of x minus 1. Okay, and then the vertical asymptote would now be at 1. And then this plus 1 is going to shift it up 1. And so it's essentially, it's going to have the same asymptote, but it's just going to look like that. So the x-intercept gets kind of messed up. It's going to be somewhere in between 1 and 2, but we don't know exactly what it is. But the thing graphed in orange is like our actual function that we're going to be dealing with. Okay, part B asks us to find the domain and range. Okay, so we can do that from the graph. So we know we have an asymptote at 1, and so our domain is going to be greater than 1, because it's going to go all the way to the right, but it will never touch 1. It will just get infinitely close to 1. Now the range, it goes all the way down, and there is no asymptote. There is no horizontal asymptote. So this will, even though it looks like it's growing slowly, it will eventually go all the way to infinity, and so we can say that y is contained on the set of all real numbers, or everything works for the range. Okay. Now let's see, part C wants find any asymptotes and axis intercepts. Okay, we already know that we have a vertical asymptote at x equals 1 from the explanation that I gave on the graph. Now the axis intercept is going to be a little bit harder. So the x-intercept happens when y equals 0. And so what we're going to have to do is we're going to have to plug in 0 to for f of x. So we get 0 equals this. And when we do that, we subtract 1. So we get negative 1 equals log base 2 x minus 1. Now to get rid of log base 2, we do a big 2, big 2. So we get 2 to the negative 1. These cancel, equals x minus 1. And so this is really just 1/2. Then we add 1, add 1. And so we think of 1 as 2 over 2 plus 1 over 2. Then x equals 3 over 2, or 1.5, so it ended up being like right in the middle, or 3/2. And so to answer the question, we have an x-intercept at 3/2. Okay, We obviously don't have a y-intercept because we have this asymptote that's blocking us from hitting the y-axis. Okay, part D says sketch the graph of f of x showing all important features. We've already done that. So we'll move on to E. It says find the inverse of f of x. Okay, so what I'm going to do, I'm going to zoom out and do it up here. Okay, so I'm going to rewrite this, but I'm going to write the f of x as a y. Okay, now with an inverse, we swap the x and the y. Okay, now we're going to subtract 1. So we get x minus 1 equals log 2y minus 1. Now we want to get rid of the log base 2, so we big 2 both sides. Log base 2 cancels that, and we get 2x minus 1 equals y minus 1. Then we add 1 to both sides, 2 to the x minus 1, and then big plus 1 equals y. And then the final thing is we got to write it in functional notation. So I just changed my y to a f inverse of x, and that is the inverse of f of x. If you need additional help, please come to Math Lab. Until then, calculator.